Right now we have coming up Anthony, and I believe Anthony is going to be talking to us about knowledge graphs and LLMs. Is that right?
Exactly. Yes. Yes. Exactly.
Okay.
Yes.
And
Oh,
I feel like that's all I've been hearing about in the last few weeks. Maybe it's just the circles that I orbit in. I'm not entirely sure, but
okay. So, I am a chief AI officer at Fribl. So we are a startup, and we are automating human resources reasoning. Okay. I am more interested in the usage of large language model for reasoning, parsing documents, automating backstage processing. Okay, not the chatbot sides. But what I will present today is also available for chatbots. Okay, so I believe RAG system, okay, Retrieval Augmented Generation, has become, I think, a new system design paradigm that every company in the world would want to implement to leverage large language model for businesses to extract value. Okay. And a recent paper has proven that RAG is better than fine tuning to integrate new knowledge. Okay, I will put it in my PowerPoint and the link. Okay, and I believe that to build a good RAG system, you need to think about it as a data flywheel. Okay, you want it to improve over time. Okay, it's the main goal. Okay, you want it to have some kind of automating the improvement over time of your RAG system and the knowledge that is behind. Okay, and I believe that knowledge graph are the ideal food for RAG system, better than vector database. I will prove that. Okay. Uh, and also, I think that over time, the models, the large language model will become better. Even we will have maybe in the future, like Lokun proposed, planning models. Okay, that model that can plan, and that's the
Anthony, real
best.
quick. Anthony, can
What?
I interrupt? Are you sure you're sharing the right screen? People are asking in the chat. We are seeing, what are we seeing? It says good evening.
Oh fuck.
I'm not sure it's the right screen.
Okay, second.
Yeah.
Sous l'écran, fenêtre. Okay, do you see it right now?
Let's see. Now we are seeing. Ah, yes. Now we're seeing it.
Okay, sorry for that. Okay.
Okay.
This was the first PowerPoint slide that I was presenting. So data flywheel and RAG system as a design paradigm. Okay. I think also RAG is important because the key differentiator of your system will be in the future the data. Okay, and you want to give the model good data, and I think that the best food that you can give at your model are structured data and relational data that is represented by the knowledge graph. Okay, and also if you okay, so how do you achieve this? Okay, first I think that fine tune is needed or might be used to increase the reasoning capabilities of your models. Okay, this is how I think fine tuning. You need to think about knowledge graph are a set of tools to reason about your data. Okay, you can use cipher queries, you can use vectorization, you can use graph algorithm. Okay, it's very rich. Okay, and you need to think the interaction between your LLMs and the knowledge graph as an agentic RAG. Okay, you will need agents that reason about what they retrieve and what they need within your knowledge graph. Okay, this is a theoretical approach. Okay, um, so this is the Venn diagram that I think about. Okay, you have the LLM, knowledge graph allow you to get some kind of reasoning, and you have knowledge. I think knowledge graph are the representation of the combination of knowledge and reasoning, thanks to graph algorithm, for example. Okay. So now knowledge graph versus vector search. I think it is there is no question. Okay, recent studies, Buller and all from MIT, has proven that accuracy is much more better for knowledge graph retrieval. Okay, yesterday, Microsoft has released a paper, a research about graph RAG. They have proven that RAG with graph are much more better. Okay, for example, in terms of diversity, you get 1.8 more diverse viewpoints per answer. You get the answer were more comprehensive. Okay, they compare it. They compare both at the same time. Okay, so I won't go long over this. Okay, now how to think the interaction between the three. And here,
Anthony, I'm going to bother you one more time.
okay,
Which side are we supposed to be on? Right now, we're seeing RAG systems and new system design pattern, a paradigm. Are you sure that it's moving
yes,
along?
because I move
Okay,
it.
now we're seeing it. Now you're on a
Okay,
cheap LLMs as reasoning engines for business.
okay, perfect. Okay. Okay, I
Okay.
will do that. I will do that from my. Okay, I think I have a problem. So this was the slide for knowledge graph versus vector search, and this one for vector search. Okay. Now, how to think the intersection between graph and LLM? And here, I think there is three intersection. Graph can be used as a context provider for your LLM. Okay, it will allow you to add some kind of reasoning thanks to graph algorithm output. For example, in the Microsoft paper, they use clustering algorithm, okay, to augment the context of the knowledge graph. Okay, this is one example of a graph as context provider. But one interesting thing that I found is that graph can be also thought as a reasoning topology, as a way for the LLM to reason about what it will be doing. It's a way to think about prompt engineering. Okay, I have many examples. You have graph of thought, okay, paper. You have a recent paper that use a Monte Carlo algorithm also to leverage the reasoning of the model. Okay. And the third intersection that is really, really interesting is that you can use transformer and LLM as graph algorithm. Okay, many papers are performing graph task thanks to transformer and large language model. Okay, I won't go in detail in each, but one paper in particular is very interesting. It's called so the model is called rare and it's retrieval augmented thought process. It takes the idea of a graph of thoughts, but each thought retrieve some knowledge base. In my case, would be knowledge graph. Okay, and there is a scoring by the LLM of the answer, scoring that we could improve over time thanks to recent paper like self-discovery. Okay, and I think that you need to think the reasoning of the model on the knowledge graph as some kind of graph. Okay, and here there is three. We can combine three ways. Okay, that I am currently testing on with Fribl. That is this paper about retrieval graph reasoning, LLM compiler that do parallel querying of some knowledge source, okay, and planning, okay, and long graph. Long graph is a long chain paradigm that introduces the concept of cyclical graph, okay. The model, if it fail at point B, can go back to point A for a different option, okay. This is in theory what has been released in the last weeks, okay. Okay, so this was the first part. The second part is using LLM for graph task. Okay, here it's very simple. You can do many things. Okay, you can look for centrality within your graph. You can look for the most influential part of your graph, etc., etc. There is paper that show that there is a great synergy between graph neural network and large language model. I won't go into detail, but I have put it here, the link to the survey. Here it is very interesting because we can imagine, this is what I am testing right now, to augment the context of the LLM with another LLM that has been trained on graph task. Okay, okay, as an alternative to a graph algorithm, because there is many advantage to use transformer for graph task. Okay, I won't go into detail. One thing that I won't go also into detail is that many people will say, okay, knowledge graph are a huge investment. Okay, but it's good to know that LLM is useful for building knowledge graph, and there is many papers. Okay, you can do this in numerous dimensions. For example, you can take your document and transform it directly into knowledge graph. You can do domain information extraction. You can do graph data model generation from a CV. You can fine-tune your model on ontology and building some domain information extraction, etc., etc. You can even use an agent system that is called AutoKG to build your knowledge graph. Okay, so it is very rich. Okay, this is the last part. The last part is graph as context providers. Here there is many gates. Okay, you got the cipher query gate. That is the query of the knowledge graph. Here you need a prior ontology grounding. Okay, this is how it works, and Neo4j has proved that. You need vector similarity search. Okay, you can use graph algorithm, and you can use also techniques that is called generative knowledge graph. Okay, I won't go into detail, but you can use these 4 gates to augment the context of your LLM. And what you want to do is to chain together those augmentation of context. Okay, I won't go into detail, but you will have the detail in the PowerPoint. Okay, and the final point, I think my system, you need to think a RAG system into 2 parts. You have a knowledge retrieval part, okay, and you have a reasoning part. Okay, the knowledge retrieval part is better used around a knowledge graph. Okay, this is my certitude, and more and more studies are proving that. Okay, for the reasoning part, okay, you want to leverage maybe different LLMs. Okay, fine tune on some reasoning task. You might want to use also maybe not forcibly LLMs, but NLP models, okay, classifiers that has been trained on your knowledge graph. Okay, let's think about that.
Anthony.
Okay, I am done.
We gotta go. I have a question. There's so many different things that we didn't get into the detail, but you've brought up to our attention. Where do we get the detail? I want to dive in. Where do we do this?
Okay, I will send my because I think I can send my PowerPoint to be public. Yes, I do believe.
Yes.
Okay.
But then even the PowerPoint, sometimes you just mention some of these things. Can we find references and other resources?
Yes. Within the PowerPoint, you will see that I linked every references that I refer to. Okay. Yes. As the hyperlink, you can click on it and you will have the references.
Nice. This is a fascinating space. I think you're almost done, right? Do you have one more slide?
Yes. This, at the last slide, I put an example for causal reasoning. This paper, okay, that I put here, prove that by using LLM on a graph algorithm, you can do causal reasoning on the causal knowledge graph with decreased complexity. Okay, you pass for O and 2 to 1. Okay, you optimize usage also as a LLM, as a causal judgment, etc. This paper, I think, is groundbreaking for the causal sphere, but it is a good proof of the combination of both graph algorithm and large language model as some kind of reasoning engine for businesses. Okay, this is my last point. Alors, all these techniques, I implement them within the startup, the Fribl. Okay, we do this for HR reasoning. I believe that those techniques with all the people that I talk to can be used in any use cases currently. I do believe that many businesses will be transformed by a proper implementation of a RAG framework. Okay, this is my belief.
Anthony, absolutely fascinating. Thank you very much. Please, everybody wants to see the slides. Yes. This was incredible. Graph neural networks. The first person that had I think introduced me to this is Aman, and he's on I think he's viewing right now. Aman, I'm giving you a shout out as well. Thank you. Thanks to you, I've been able to appreciate Anthony's presentation even much more. So Anthony, thank you very much.
Thank you for having me. Thank you. Thank you. Have a nice night.